All right, so for each one of these, as we review polynomial operations, we do have specific tasks to do. In this very first one, we are going to distribute the negative first. So now I can rewrite that. So I put a plus there, a negative there, and a positive there. I just oppositify everything. Now I can begin to combine like terms. My 4x combines with the negative 3x to give me x, and the positive 2 with the positive 8 to give a positive 10. And now I have my polynomial simplified. On the second one, we do the same thing, except we don't have anything to distribute. That is important. So we combine the x's to be 7x, and we combine my constants to be negative 6, and 7x minus 6. This is in standard form because my variable comes first, my constant comes last. And our last one here, you can recall that we can do FOIL or double distribution. I will just walk through it like this. We multiply those two to get 12x squared. Then we multiply those two here to get negative 32x. Then we multiply these two here to get 6x. And lastly, we multiply these two here to get negative 16. We also make note here that I have some like terms. These two are like terms, so I can combine them. So I'm going to bring down the 12x squared. I'm going to combine my like terms to get negative 26x, and bring down my constant there. And when you commit to it, you put a ring around it. We're going to take exactly what we just did with polynomials, but we're going to apply it to complex numbers. Turns out the rules are virtually the same. So when adding or subtracting complex numbers, or when adding, subtracting, or multiplying, we're going to treat complex numbers the same as like terms, like we did with polynomials. The only difference is this. Sometimes we're going to get an I squared. So we have to simplify to be 1. Sometimes we get an I squared, so we have to simplify to get 1. All right, in our first example, our instructions say that we're going to perform each operation. So we just look pretty much in the middle there to figure out what we're doing. And we're going to leave our answers in standard form, which are always like this, a plus bi. So looking at a, we're going to combine my like terms. Again, the 5 and the 1 are my like terms, so simply 6. And I minus 2i, we treat it just like we would if it were a polynomial, x minus 2x. So you would say minus I, and that's it. We're in standard form because I have my real number first, my complex number second, or imaginary number. And there is no square to have to simplify. So in problem B here, since we are fundamentally doing a subtraction problem, one complex number minus another, we have to send that negative in by taking the opposite of both. So that means the 1 becomes negative and the 2i becomes positive. And now we can combine like terms. I have a 5 minus a 1 to get a 4. And I have an I plus a 2i. So in this case, I get 3i. Woot, 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 bing! So after you work through the practice, this is what you get, and you can pause to see your answers. Should. All right, so let's perform each given operation. In this case, we look between here, and since there is effectively nothing, the parentheses mean we are multiplying. So I'm going to apply the rules of FOIL or double distribution to attack that. So let's look here. I'm going to send the 1 to the 3 to get 3. I'm going to send the 1 to the 5i to get 5i. I'm going to send my negative 4i to the 3 to get negative 12i. And lastly, I'm going to send the negative 4 to the 5, negative 4i to the 5i to get negative 20i squared. So the first big step we do is double distribute, also known as FOIL. All right, seems I did make a mistake, so let's go back. Punch me in the neck. It is negative 1 here, so please go and change that. So now we're going to do two things. Number one, I'm going to combine these two like terms to get negative 7i, and I'm going to bring down the 3 because it doesn't combine with anything yet. And what I do notice also is the I squared here, by definition, I squared, as I saw I made that mistake earlier, is negative 1. So watch the magic here. Watch the magic. Effectively, I do this. The I squared is negative 1, so the 20 now becomes positive. So I'm going to bring down a 20. So I combine my like terms now.
If I wrote negative 7i.
So we combine our like terms with the 3 and the 20, and we put that in the very front. So the big thing we notice here about D is that we still have a product of two binomials. So we have 4 minus 5i and 4 plus 5i. But the key is that these are conjugates. So that means I can use this super secret rule, a minus b times a plus b. And all we have to do is square the first term, subtract, square the second term. And that's it. You can do FOIL. You can do double distribution if you like sadomasochism and to torture yourself. But rather, let's be efficient with our time and use that. So all you do is take your 4 here and square it, which you don't have to write. You could just do that in your head. Then we're going to take our 5i and square that. So I'm going to put that in parentheses so you see what's going on. It's not just the I being squared, but all of it. And we will always have a subtraction to begin with. So I put a subtraction there. And now we begin the journey of simplification. 16 minus 5 squared is 25. I squared is negative 1.
So it's positive.
So now we get a double negative here. So I am going to change that to a plus 25. And so my answer is 41. 41.
What if you tried to do it?
And now when we practice, in number 17, it's a single distribution. And notice here that my my I squared changes this positive to a negative. On number 19, we have double distribution that occurs. And when we do that, we have 4 terms. My I squared changes this to a positive. And these two here combine to be a 2i. And then we can combine those two puppies to be 4. And the same applies here, and you can pause to see number 20.